Good day, Bayaws. Welcome to our YouTube channel, Bayaw Tutorial. In this video, we are going to solve a problem from Thermodynamics and Heat Transfer, Chapter 4, the first law of thermodynamics. So here is our problem. At a certain point, a piston cylinder mechanism contains a 0.35 kg nitrogen gas at 140 kilopascal and 180 degrees Celsius. The nitrogen is now expanded isothermally to a pressure of 110 kilopascal. Determine the boundary work done during this process. So we have a illustration for our problem. So inside the cylinder, it contains nitrogen gas at 140 kilopascal, which is the value of our pressure, and the value of our temperature is 180 degrees Celsius. But before we are going to solve what is determined in this problem, we need to identify first the given values. So we have P sub 1, or our initial pressure, which is equals to 140 kPa. And for our final pressure is equals to 110 kPa, which is the pressure that the nitrogen gas expanded isothermally. The value for our temperature, which is equals to 180 degrees Celsius, and the value of and the mass, which is equals to 0.35 kilogram. And we have properties for this problem. The property of nitrogen, you can see this at table A-2. The value for our gas constant, or R, is equals to 0.2968 kilojoules per kilogram Kelvin, and the value of K, which is equals to 1.4. Now that we all identified all the given values, we can now proceed to our solution. So we are going to determine first the initial and final volumes from ideal gas relation and find the boundary work using the relation for isothermal expansion of an ideal gas. So we have this equation. Initial volume is equals to MRT, or the mass, multiplied by the gas constant, and the temperature divided by the initial pressure. So by plugging all the given values, we have 0.35 kilogram times 0.2968 kilojoules per kilogram Kelvin times 180 degrees Celsius, and we need to convert it into Kelvin. That's why we add 273 Kelvin divided by 140 kilopascal, and it is equals to 0.336126 kilojoules per kilopascal. And because we are finding the value of our initial volume, we need to convert this unit into cubic meter. So we are going to multiply 1 kilopascal cubic meter is equals to 1 kilojoule. So that's why the kilojoule unit is going to be crushed out and the kilopascal. And what we have left now is the cubic meter. So the value for our initial volume is 0.336126 cubic meter. Now, we need to identify next is the value for our final volume. So by using the same equation, we have 0.35 kilogram times 0.2968 kilojoules per kilogram Kelvin plus 180 degrees Celsius plus 273 divided by 110 kPa. We use the 110 kPa as the value for our pressure because it is the pressure in final. And in this problem, or in this equation, we are finding the value for our final volume. So by simplifying this equation, we can get the value of our final volume, which is equals to 0.427797 cubic meter. Now that we have the value for our initial volume and final volume, we can now solve for our boundary work. So the boundary work is equals to initial pressure times initial volume times ln of final volume divided by initial volume. So by plugging in the given values, we have this equation. So 140 kilopascal multiplied by 0.336126 cubic meter times ln of 0.427797 cubic meter, which is the value for our final volume, divided by the initial volume, which is equals to 0.336126 cubic meter. And by simplifying this equation, we get the value of 11.34978 kilopascal per cubic meter. And since we are determining the boundary work done during this process, our unit here is kilojoules. So we need to convert it into kilojoules, and 1 kilojoules is equivalent to 1 kilopascal cubic meter. So by multiplying this equation, we can now get the value for our work boundary, or the boundary work done during the process, which is equals to 11.34978 kilojoules, or 11.35 kilojoules. So that's it. Here is the answer, or the final answer for this problem. So now we are determined the boundary work done during the process, which is equals to 11.34978 kilojoules, or 11.35 kilojoules. So that's all.